Good afternoon, Year 5, and welcome back to our virtual classroom. In today's math lesson, we are going to be comparing two simple fractions. This is what we left off on before we had to leave school, so it should be familiar to you. Follow along closely because today's independent work is going to be quite long, so it's going to be a short one from me, a lot of work from you. Get us started, let's do a little refresher of these symbols. The greater than, less than, and equal to sign. You know we use this when two things have the same value. And then these two, think of it like a crocodile mouth. Remember, it eats the bigger one. So it's not pointing to the bigger one, it's actually eating what's bigger. So what's bigger should be on the open side of the mouth. Now, let's say we had two simple fractions, a half and a fifth, and we had to say which one's bigger. So which one does the crocodile mouth eat? Some people are tempted to say 1/5 is bigger because 5 is bigger than 2. However, with fractions, it's a little bit different because when we see a half, that means we have 2 pieces. When we see a fifth, that means we have 5 pieces that make up the whole. So that means we have 1 out of 2 versus 1 out of 5. This is what that actually looks like. Here's a half. So 2 of these would make up the whole. For a fifth, you need 5 pieces to make up the whole. So the pieces that make up the whole for the fifth are all a little bit smaller. So if I compare them side by side, I see a fifth is actually quite a bit smaller than a half. Now the rule that you need to keep in mind, the bigger the denominator gets, the smaller each piece is. So since our numerators are the same, they're both 1, we know that 1/5 is actually going to be smaller because its denominator is bigger. So whenever the lower number gets bigger, the pieces are getting smaller. The way that we compare these in class, other than using visuals like these, there's the strategy of cross-multiplying. So remember, all you do, take the denominator from one side, multiply it by the numerator on the other side. 2 times 1, I've gone this way, my answer is 2. So I'm moving upwards. 2 times 1 is 2. 5 times 1, moving upwards, is 5. Which side ends up having the bigger value? 5. Now the reason for that, all we've done is we're actually finding equivalent fractions. So I've told you in class we can stop at this step, but the very first time we looked at this, we were actually working out equivalent fractions. So if I took 2 and multiplied it by 1 and multiplied it by 5, 1/5 is the same thing as 2/10. Why? Because 1 times 2 is 2, 5 times 2 is 10. We've done the same thing to the top and the bottom. I just found an equivalent fraction with a denominator of 10. If I do that to the other side, but I multiply by 5, I multiply the top by 5 and got 5, so I have to do the same to the bottom. 5 times 2, still 10. So what I've really done is created fractions with the same denominator so that I can compare them easily by just looking at the numerator. And in this case, this has the larger numerator, so a half is bigger. Let's look at some more, but we're just going to focus on cross-multiplying and do it a little bit quicker. In this new problem, I'm comparing 3/4 and 6/7. So I'm going to cross-multiply to find these because you will not always have fraction tiles on you to make a visual. So it's more realistic to use a paper method. So for me to cross-multiply, I'm going to use my denominators, 4 and 7, and multiply the other side by them. So I'll do 7 times 3. Moving upward, 7 times 3 gives me 21. And I'll cross the other way. 4 times 6 gives me 24. Well, which side is bigger? 6/7. That means when I do my final answer, I can confidently say 3/4 is less than 6/7, or 6/7 is greater than 3/4. Let's make another one. How about we do 3/10 and 6/20. Okay, well, I need to cross multiply again. 20 times 3 is 60. 10 times 6 is 60. So I got the same thing. What does that mean? Well, they're equal. Let's do another one. I'm going to erase my board now. Notice that I'm not going to be using the arrows every time. I find that just makes it a little bit confusing. When you know the strategy of using the arrows, just imagine that you drew the arrow and simply write your answer off to the side. That keeps your paper a whole lot neater. Let's do 5/8 compared to 9/12. Hope you know your 8 times tables and your 12 times tables. 12 times 5 is 60. I hope you guys are shouting this out before me, like Dora the Explorer. 8 times 9 is 72. So, which side is bigger? 9/12. So now I can just write my symbol in the middle that shows that the crocodile mouth eats 9/12 because it's larger. That's why I don't always like to do the arrows, because now I have my space in the middle to do my answer. What I'm going to do is give you guys about 10 questions like these, and you're going to solve those in your notebook, take a picture, and send it to me.